Alright folks, the first time we're trying this out, we'll see how it goes. But what I have here is an actual application problem up front for your notes. Hopefully at least you take a look at this and jot some things down. This is a pretty hefty one, and we're going to start this kind of pattern of talking this when we talk about quadratics and parabolas and all of a lot of information that we can get from them. And the different things that we can be asked from those functions. So I'm going to stand back here for a second and read this off, give you some time to jot things down if need be. But a rocket is launched from a platform. Its height in meters, x seconds after launch, is modeled by the function right there. We have in purple h of k is equal to -4 times quantity x plus 2 times quantity x minus 18. We have 4 separate questions there. The first one is, what is the height at launch? The second one is, how many seconds after launch will the rocket hit the ground? Third one is, how many seconds after launch does the rocket hit maximum height? And then finally, what is the rocket's maximum height? So a lot of information to take in. What we'd like to do first, though, is I see this word problem, and my personal opinion is the most important thing to do to start up front is to understand exactly what the variables mean. So we see an x in the function on both sides, left and right. We have the h of x there, so usually that operates as a y value when we have a picture and a graph, but here we have a function. We're dealing with a word problem, so it's in that function notation. Let's go ahead and figure out what those things mean. I'm going to try to make as much room over here as possible. So before I even answer questions like this, I'm going to go ahead and just label things. So the first thing I'm going to see here is I have x and h of x, and trying to figure out what those actually mean. In the problem up here, it says a rocket is launched from a platform, its height in meters, x seconds after. So I see the phrasing here, x seconds. All right, I think that from that I can take pretty handily that x is an amount of time. In this case, we're talking about seconds. All right, so I'm fairly positive that x is the amount of time here in seconds. And based upon how many seconds have elapsed, we know that the height in meters would be kind of acting as our y value here. We have h of x, so the h definitely helps the concept, and that the h of x here is talking about height, and specifically in this case we're talking about meters. So up front, before we get rolling with the problem, doing something like that I think will greatly help our chances in doing all these problems correctly. The very first question says, what is the height at launch? What is the height at launch? The key phrasing there is a couple things. The first thing is that the question is asking us, what is the height? We know that height here is h of x, so we're going to have to calculate something where we know what the final answer would be for height. And then secondly, in this problem, the concept of this happening at launch is a huge deal. So if we're trying to figure out what the height is going to be at launch, we have to understand how many seconds have elapsed at launch. Hopefully we understand that the beginning of the rocket moving happens at launch. So obviously it's at a standstill, and then all of a sudden launch happens, and now we're moving the rocket. So with that being said, in this case, at launch, no time has elapsed. We're starting the process, so our number here would be 0 for x. So to answer number 1, x is going to be equal to 0. We need to figure out what will h of 0 or the height be at the beginning of the launch. So now that I know that the x value is 0, I'm going to take that function, I'm going to plug in 0 wherever I see the x, and we'll do some calculations. So I'm plugging in 0 wherever I see the x value, and I have to do some math work here. -4 is our a value out in the front, 0 plus 2 is 2, 0 times negative 18 would be negative 18. Then I multiply some things out here. I have negative 4 times 2 times negative 18. Got to do a little bit of thinking here. Negative 4 times 2 is negative 8. Negative 8 times negative 18 would be 4, 4, 1 coming across there. Yes, I do believe that would be it. It's 144. 144. That is our height at the beginning of this problem. So the height of the rocket at launch would be 144 meters. The second question says, how many seconds after launch will the rocket hit the ground? Again, when it comes to this problem right here, a couple things within the question is very, very important to us. The first thing is, it's asking how many seconds. So we know in this problem, we're trying to figure out how many seconds we're going to have to solve for x, because x is talking about time. After the launch will rocket hit the ground, the phrasing within this question lets me understand that I'm understanding hitting the ground is a pretty big deal in this problem. Now, within this concept of this problem, what does hitting the ground mean? Well, we know in this problem we're going to have to solve for x. H of x is the height. And if the rocket is hitting the ground, that means that our y value, or in this case h of x, has to be equal to 0. So, if we know h of x, or maybe you'll see it sometimes as a y value, has to be equal to 0, we are looking for here the x-intercepts. If you remember from the graphing problems we did, every time that we started a problem in intercept form, we had to figure out x-intercepts, and it was some number, comma 0, and then usually there was another some number, comma 0. So here, if we're trying to figure out the x-intercepts, this problem is really set up for us here, because we have two parentheses for our functions. We have an x plus 2, and we have an x minus 18. So I look at my x-intercepts here, x plus 2, what number would we plug into that parentheses to make the number 0? And hopefully we understand that negative 2 would be the number that if you plugged into the parentheses right here, negative 2 plus 2 would be 0, and that's the end of that. The other parentheses here is x minus 18, again trying to figure out what number could we plug into that parentheses to give us a 0, and hopefully you figured out that it would be 18. So we have x is equal to negative 2, we have x is equal to negative 18, and the question here is asking how many seconds after launch will the rocket hit the ground. So, since it's a question asking about amount of seconds, we have our answer here is at negative 2 and 18 seconds. Now hopefully at this point you're thinking to yourself, wait a minute, one of those answers doesn't make sense. There's no such thing as negative time. And the last time I checked, we haven't invented time travel yet, so there's no going back in time and making a negative amount of seconds. So even though algebraically our answers here is negative 2 seconds and 18 seconds, the rocket will not be hitting the ground at negative 2 seconds. That's impossible. So because that's impossible for this problem, we're just going to go ahead and cross that out, and we'll go with the final answer, which is that our rocket here will hit the ground at 18 seconds. All right, so a little bit of thinking, a little bit of common sense coming into play here in that problem. And we're trying to figure out how many seconds when the rocket hits the ground. -2 seconds is impossible. 18 seconds is certainly something that's available to us. The third question says here, how many seconds after the launch does the rocket hit maximum height? Again, going through the questions within that problem and the words in that problem, we see the word how as a question word and asking for seconds. So once again, when we do this problem here, just like we did for number 2, we have to understand that the question is asking us to figure out a measurement of time. So we're going to go ahead and try to figure out x at some point within this problem. We go on to read the problem. How many seconds after launch does the rocket hit maximum height? Hopefully, of all the words you just read out loud there, the idea that it's a maximum really sticks out to you. We understand that if we see the word max, or if we were to see the word minimum in a problem, that means that we need to head towards the vertex. So in this problem, for number 3, we need to figure out the vertex. Since we're solving for the letter x, because it's a question about time, within the vertex, we know that our x value for the vertex is our axis of symmetry. So, just like we did algebraically before, we need to figure out the axis of symmetry. Now, our 2 points, our 2 intercepts here were -2 and 18. So because -2 and 18 were our x-intercepts, what we can do is figure out where the middle of those 2 numbers would be. And you could do this with using a number line or draw a graph and do that, or we could just use the very simple formula that we had before, where we took the 2 numbers and added them together and then divided by 2 to find the midpoint. So I have -2 plus 18 divided by 2. -2 plus 18 would be 16, and 16 divided by 2 would be 8. So in the question, how many seconds after launch does the rocket hit maximum height? It would take us 8 seconds to get to the maximum height. Again, we understood that the question was asking for a time amount. It said the word maximum in the problem, so I have to go to the vertex. Since it wanted the x value of the vertex, we know that's the axis of symmetry. And we're able to use our formula and try to find the midpoint between our 2 intercepts to get the maximum location for the x value. Finally, a lot of information coming from this problem. The final question is giving us what is the rocket's maximum height. So again, go to the question here. Understand that we're asking a question about height. So when it comes to a question about height, we're talking about the h of k. So when we solve this problem, or when we figured out this problem, we're trying to figure out the height at a certain point. And it even tells us in the problem, a pretty important word sticks out to us, hopefully, that we're trying to figure out the maximum height. So if we're trying to figure out height here, and we're needing a time measurement, we already just figured out in the last question that it would be 8 seconds for the rocket to get to that maximum location. Now we can plug that 8 seconds in to get the actual height for this rocket. So I'm going to take our function and I'm going to plug in 8 seconds. Why am I plugging in 8 seconds? Because 8 seconds, we know that we're going to have the maximum height. We just got to calculate what that height actually would be. So wherever I see an x in the original function, I'm going to go ahead and put it in. And I'm slightly going off the picture here, and that's all right. But I'm going to plug in 8 for everywhere for x. I have 8 plus 2 is 10. I have 8 minus 18 is negative 10. And I got to multiply all this out. Negative 4 times 10 is negative 40. Negative 40 times negative 10 would be positive 400. So at 8 seconds, we know that our height's going to be at the tallest location possible. That actual height amount would be 400 meters. So an awful lot of information. We're still using all the things that we did when we actually graphed the thing. At some point in time, we had to figure out x-intercepts. At some point in time, we had to consider what the axis of symmetry would be and what that vertex would be. This right here is our maximum location, so we know that would be the vertex point on a crazy, very large graph. At the point x is 8 and y would be 400, that's our max location. We also had to figure out at the very beginning of the problem what the y-intercept was, which we did algebraically a couple times in previous videos.